So number 17 then from paper 2 of the 2025 Advanced Higher. Just a wee 4-mark question here for, looks like related rates of change. So what does it say? The volume of water in a tank, V, is given by this. V equals 1/5 of h cubed. So it looks like some sort of cuboid, where h is the depth of the water, right? Water's been piped in, so going in at a rate of, so this is the change in the volume. The rate of change of volume is going to be 6 centimetres cubed per second. I'm not bothered putting it in if all the units are consistent. But it's leaking out, so there's another rate of change of the volume at a rate of, so it's going out, so that'll be a negative 1/10 root h centimetres squared per second. And you have to calculate the rate of change of the depth, that's h, when h is 400. So what I'm looking for is this, I want the rate of change of the height. I don't have a formula connecting them. That's why it's related rates of change. I do have a formula connecting it to V, I mean. So I can do dH by dV and then multiply that by how fast the V is changing with respect to t. Because I've got both of those, although I haven't stated that one yet. dV by dH will be multiplied by the 3, and take one off would be that. Now, I should really be combining these two to get the net one. I don't know why I didn't do that at the time. So the overall, the net rate of change of the volume is going to be 6 minus 1/10 of root h. I should have done that before I wrote this down. I'll just put it all together. So you've got dH by dV, that'll be, invert that, so it'll be 5 over 3h squared, multiplied by this one here, 6 minus 1/10 of root h. So that's what I'm looking for. Now that obviously depends on h. So it says what happens when the height is 400 centimetres. Well, if the height is 400, the rate of change will be 5 over 3 times 400 squared times 6 minus 1/10 of 400. You could just press the buttons there and that would do it. So that comes to 4. So that makes that a 20, and that's a 1648 with 4 zeros. And then I can divide that, knock off a 0 and half that. 1 over 24,000 centimetres per second. That's minute. Or do they want it as a decimal? That would be 0.0000417 centimetres per second. Positive. So it's creeping up by about, well, a molecule a second in height. If that's right, I suppose I could do a quick sort of check, because it looks really small. It makes you think you've done something wrong, doesn't it? So if it's at 400, how much would you actually have to pour in to get it just to got 1 centimetre? Because look how much it's going up in a second, it's hardly anything. So if I wanted the change in the volume as it went from 400 in height to 401, that would be 1/5 of 401 cubed minus 400 cubed. Let's just use that formula twice, which would be 96240 and a bit. So that's, in order to make that go up by 1 centimetre, you'd have to add this 96,240, but it's only going in at 4 after all. So I suppose so, because so that means the time it would take for that to happen would be 96240 divided by 4, so that's 24060. That's more or less the same as that then, isn't it? Because if that's the time it takes to go 1 centimetre, then the number of centimetres that will go in 1 second will be the reciprocal of that, which is 1 over that, which is what we had.